Hi, this is Brent from Theoretically Practical, and this week's video is going to be a bit of a continuation of last week's video on putting an Arduino into a Miller wire feeder. We're going to be going over the wiring diagram to help hopefully demystify that for anyone trying to follow this project, and we're going to show people that have never touched an Arduino before how to connect and log in and set it up their very first time. It's a pretty simple process, but it's a little involved, and we're going to try to make it so that if you've never touched an Arduino before, if you can run a soldering iron, you can complete this project. And finally, we're going to be dealing with the bug in the code in this. I know, a bug in the code, for me, how could it be? But it is, because currently if I turn this on and flick this trigger really quick, the wire will start to feed and it will not stop. So we'll go through this, we'll get it fixed, we'll get it working, and if you got one of these, we'll get you on your way. There was a small error in my code. I did not anticipate that I would pull and release the trigger as quickly as I do. Now, actually forcing myself to work around that a little bit today, it's kind of a bad habit, but the problem is the feed will remain on and everything will remain hot if you tap the trigger quickly. And I'll show you what I mean by that. So this is how it's supposed to work. You can see the wire and you can see it stop. This is what happens when you pull the trigger really quick. And you see it's feeding right away, not what it should be doing. And you can reset it, so that's good, but we're gonna go in there and fix that. You can see right now, we got the Arduino here. It's plugged into the computer here. I don't need the welder to actually be on, but I did take the trigger source right here off the opto isolator so I can push the button. So if I push the button slowly, it all works. But if I just wrap the button, then the feed and the power stay on, but the gas shuts off. So it's even a little worse than that. And then once you get it all screwed up, it's all screwed up. Interestingly enough, that problem does not show up in spot mode. So if I just tap the spot mode, it just runs a quick spot and turns off. I think that's going to be the key to figuring out what I did wrong with my logic. I did try to reverse the order of my on trigger looking, my rising edge trigger, my falling edge trigger, sort of if statements, but that wasn't it either. So I'm going to plug away at this for a little bit, and when I figure it out, I'll come back and let you guys know. Okay, so that was actually pretty easy to sort out. I'll show you a little more in the Arduino code, but essentially where I turned the gas off with my timer, where it says if 3 and current millis is greater than gas off millis, 3 equals false, for whatever reason, it's kind of picking up the tail end there. So now, anyhow, I have it in continuous mode and not spot mode, and if I just tap it, it just shuts right back off again. So, and we'll put it in spot mode, just make sure we didn't screw that up. So we'll do one spot full hold down. Perfect. And a spot quick. Perfect. So that's all working great now. This new version will be updated. It's 2 lines of code, really. I rearranged the order of some stuff, but that was just me trying to figure something out. I'm going to stuff that back in, and then we'll look at the code real quick, and I'll pull up the wiring diagram. The first thing to do is get your Arduino connected to the machine. So it's just a USB cable. The nice thing about the way I have it set up now is that if the USB cable is powering everything, you can fire the relays, you can do all that stuff, and then if you unplug that, I don't think it even matters if you have it plugged in though, but if you unplug that and turn the machine on, then the power comes from the power unit. You can see actually the power unit ends up getting, or the power supply ends up getting a little lighting up the LED on it, but that's just nothing to be concerned with. So anyways, you got it lit up like that. I do have the correct version of the program installed, but I'm just going to re-upload it so you can see the sequence of lights. So when you hit upload, you see how it blinks, and then it blinks a bunch more, and then your computer will momentarily lose communication with it, and then it comes back up, so it's good to go now. All right, and then if you are if you've just connected to your computer, Install the Arduino IDE, install all the drivers. There are so many videos on that subject that I'm not going to add anything to that. But if you've got it installed and you're just having some troubles, what you have to do before you upload is you select tools, you select the board. So I know I have an Arduino Micro. I will say some of the Pro Micros I've bought on eBay show up as Arduino Leonardo, and then you would show them that. But it's pretty easy because you click on your serial ports, it'll say COM something, and it'll say Arduino something else. So you select that port, and then if you're still not sure which one you have, you can click Get Board Info, and it says BN, board name, Arduino Micro. And there's other information that you can get about it as well. But so all you have to do is open this up in whatever, in the IDE on your computer. I think you can use the online IDE, but I haven't. I hate the idea of everything being in the cloud. I like my software on my computer where I have control. It's not really a surprise. I'm a controls engineer. I want things the way I want things. So we've come down, we've selected the board, we've selected the board in the boards manager, and we're all set up. And then we just hit upload, and that's it. And you see what it should say some of the stuff. You get the green thing, and it'll say done uploading, and it'll tell you how much of your memory you've used. I have filled up Arduinos, but this is not going to. Okay, so here we have the wiring diagram. So it is pretty simple. I know this looks like wire spaghetti, but a lot of the stuff is going to the same places. So, all these orange is all the plus 5 volt regulated from the Arduino. All the black is the ground on the Arduino. So anywhere the black wire goes. So, these little relays, you got to give them power and minus. You can feed them with external power as well, but we're not getting into that. But also note the jumper is set in a specific position. There could be different variants. A lot of these things have different varieties that they sell at different times. So look at the documentation anyways. And then each one of them has, so the left is the plus 5, the right is the ground, and each one of them has an input. And they're just hooked up to 6, 7, 8, and 9. So they're all outputs on the Arduino. The only thing that's a little confusing here, the opto isolator, you just may not be familiar with them, but for all intents and purposes, it's a relay. It's just a switch controlled by light. That's a gross oversimplification, but that's all that really matters at this point. And then the rest of this is pretty simple. You'll see there's one relay that's not used. It's still wired up because it's easier to wire it now than later. This UBEC is actually for one that is a little bit light for this. There are a bunch of UBEC. They're done by S of LiPo, and each S is like some amount of volts. It's for hobby controllers. I just like them because they're a really nice little package that does a wide range of DC input. And I've hooked one of these up inside of a cabinet for a little 24 volt Arduino display. It's been 3 or 4 years now. They work fine is all I'm trying to say. And then the potentiometers, just make sure they're a 10K pot. You don't have to use a 10K potentiometer, but that's what I almost always use with the Arduino, and it's good value. It's going to work for you. Yeah. So let's go on to the code. So I don't use all of these unsigned ints at the top. I just didn't want to delete them afterwards. It's hard to delete something from something that works. So these are supposed to be used. Oh, let's see what I do with them. Gas time pre, gas time post, feed time, power time. So these are where I want to read my analog input values. They don't have to be unsigned ints, but I know they're going to be between 0 and 1024, and I don't want to have to deal with what if they're negative. They just can't be. So that kind of simplifies that. Unsigned long current millis is just a place for me to store the current milliseconds of the clock. This is, I want to say you could probably make a timer up to like 3 weeks with this before it will overflow and spin back around. Gas off millis, power off millis, power on millis, and power off millis and spot millis. These are all the places where I'm going to hold the times that I want to turn it off at. So the difference between here and here will tell whether it turns on and off. Bool spot is false. That's where I'm going to say, is the spot timer on and off? Bool trigger is false. That's where I'm going to say, is the trigger pulled in or not? Last trigger is to help me do a falling edge thing, so it'll only run some sections of the code on the change. This was where I had a little bit of trouble with a very quick press. Spot trigger, I don't think I use that. And 1, 2, and 3 are just like stages 1, 2, and 3. I want them to sort of cascade through each other. This is the setup. This only runs once. So I'm setting pins 4 and 5 as input pull-up, and what that just does is it pulls them to high. So if you put a voltmeter on there, or if you could measure the voltage, it'd measure at 5 volts. You connect that to ground, and because it's such a low amperage signal, it pulls that to 0. This is nice because you don't need to use an external resistor. So I almost always do this, but it inverts your logic. But you'll see that when I read it in, I invert it again, so it cancels itself out. But that's definitely the way to do that. 6, 7, 8, you want to set them as output. You don't need to pre-configure your analog pins. The other thing is with these particular relays, 1 is off or high or 5 volts is off and low is on. So these are also backwards, just to keep it simple. The serial.begin just starts a serial socket, if you will, at 9600 bytes per second of information. That's helpful for debug. I might actually comment that out. I try to get rid of all that when I'm done, because the Arduino is so sort of lightweight controller that you can really pick up a lot of performance by optimizing your code well. So this is the loop. It'll just keep running once after the other. If you've done stuff with PLCs, this is not like PLCs, where PLC will run the whole loop and then output it. This will do the line and then do the next line. So if it turns on one line and off on the other line, it'll flicker. Whereas in a PLC, it only ends up at the last state. Just something to notice. So current millis equals millis. Every time I want to go through, I want to pick up that loop. Now, I do this because each loop is only going to be a few milliseconds, and it takes some amount of time to read millis into current millis. I believe. Someone could correct me if I'm wrong. So I want to run that function once. Same thing with the trigger. This also means that the trigger will stay in the same state for a complete loop, which is a helpful thing as well. Because and again, running the digital read function once is going to, I think, make this more lightweight. Someone better at optimizing has some information. I'd love to hear it. So if not trigger, and here you'll see serial.println, analog read A0, A1, A2, A3. I put each one of these lines in at a time so that I could move a dial and see what the number did, so I could know which dial went to which one, which is why I wasn't concerned when I was wiring them up. Because if you just comment out this line and hit upload, because we don't know what's serial read analog 0. So we're uploading, and then we'll do tools serial monitor, and it's 0 right now. So all right, I turned the post flow trigger, and you can see the numbers go up and down. That's how I know that that's the post flow. So that's just how, and then I also put in the comment after it, this is post flow time, 250 milliseconds to 500 milliseconds, 25 to 250, just to set the times of those. You know, like the spot timer is 250 to 5,000 milliseconds. I guess I did that for all of them. So quarter a second to 5 seconds. Gas time pre, gas time post, feed time, and power time. It takes A3 in, and or A3 or A0, A2 or A1, takes a variable in, and the output is going to be from 0 to 1024. So this is gas time pre. You're mapping an analog read of the A3, which we serial just printed just now, so we know it's going to be 0 to 1024. So you have 0 to 1024. Scaled that to 250 to 5,000. The map function's really handy. It works well. And then the final one is spot equals the opposite of digital read 5. So if spot is true, it's in spot mode. If spot is false, it's not in spot mode. I wrapped all this in an if statement so that it's only reading and updating these values while you're not pulling the trigger. That'll save a little bit of cycle time here, I think. And again, we're talking about milliseconds, but I'm trying to use this as a millisecond accurate timer without going overboard. And this is a pretty small way to do it. So if trigger equals false and trigger does not equal last trigger, Basically, last trigger is set to false when it's false and true when it's true. If it's changing, so once you've, like say you press and hold or leave the trigger off, it on the falling edge, on the trigger going false, it'll say, is trigger false? Yes, it is. Okay, and does trigger not equal last trigger? So is last trigger true? Meaning the last time it went into this little function, is it true? You'll find out that the first time it was true, so it says, okay, it sets 2, 3 is true, last trigger is false, turns that on and sets your timers basically for shutting down. And then this is a rising edge trigger. The other thing is that if this covers turning the trigger on, this covers turning the trigger off. And then spot trigger covers turning the trigger off even if you're still holding the trigger. So if spot trig is true, so if you ever just say is spot trig or is exclamation point spot trig, you're either saying is spot trig equal true or is spot trig equal false. It's just a really quick notation method. A lot of IDEs support that, or a lot of programming languages support that. And the double ands, meaning and current millis is greater than spot millis. So basically your spot timer's done. This sets the shutdown off. So this is step 1. So you've pulled the trigger, the gas is turned on in the if statement we looked at up above, and then current millis is greater than power on millis. So now it's time to turn the power on. So 1 is false, we're done with that. We'll turn 7 low and 8 low, which is the feed and the power relays. Again, low is on. So then when you finish, 2 is true and 3 is true. So if 2 is true and current millis is greater than power off millis, then you're gonna turn the power off. And this is because the feed is turned off first. The power off is for the burn back setting. And then if 3 and current millis is greater than gas off millis, 3 equals false. And then it turns everything off. And that was what I added in. Before it would just turn the gas off. But for some reason, when you push the button really quickly, it would kind of, I don't exactly know what it was doing wrong. It was still running this statement, so I just put them in there. It clears everything out, and that's it. You know, it's less than 100 lines of code, and a lot of it's pretty not very dense. There's a lot of other really good Arduino sources, so you know, this is just kind of if you just want to do this project, you don't want to touch Arduinos again, this is the video that you should watch. So now I'm going to unplug it, button everything back up, and I'll prove to you that the new update works. Okay, so it's all buttoned back up. It's all back together again, and we'll see if I screwed it up or not. So there we go. We're gonna hold it for a little bit to make sure that it still works just as it did. Okay, everything good there. But what happens if I just give it a quick flick? Just nothing. Basically what you'd expect. And then we'll go to spot mode. And we're gonna, yep, just a little bit. And then we're gonna hold it. Perfect. So we are all back together again. One day I'll clean up all those midwires from the floor of my garage. I won't. You know that. It's all back together again, and it's working exactly as intended. So I'll put this version up. I know I call a lot of this coding stuff simple, and I also know that I've been messing around with it in some form or another for more than 20 years, which is a scary thing to contemplate. Oh God, almost 30 years now anyways. If it doesn't make sense to you, that's fine. I hope that what I provided you could get somebody without any knowledge of Arduino through this process successfully. But there are 1,000,001 tutorials, and when I started out getting into Arduino especially, what I typically would do is find whoever documented a project that was the same or similar to what I was trying to do the best. I would copy shamelessly whatever they did. So it's a great starting point usually. You often have to still tweak the code, but yeah. So anyways, have a great day, and see you soon.